let's get into statistics. Why do we need statistics in the first place? Oh, this is the part that we did on one of the takes.
Yeah.
Oh, this is the part that we did on one of the takes.
Like, okay.
Yeah, I remember. Okay, yeah, this is the part that I forgot about. Yeah. So, why do we need statistics, right? So, the best thing for us in the world of statisticians and mathematics is to do what we have. And what we have is data. Bunch of it. And the best thing that mathematicians, or at least I should say statisticians, know how to do is to use past data, previous knowledge, and assume things about the future. That is the whole study of statistics, basically. To take data that you've obviously already taken, so it will be inherently from the past, and you're assuming something about what will happen. Now, there is a level of uncertainty to it. There is a level of preciseness to it that could be wrong, could be off. Well, but that's the whole idea of studying statistics.
It's not only to predict things about the future, but sometimes you just want to like analyze a situation.
You're
For
right.
example, we
and
had a
analysis
lab.
As well.
We had a lab where we had like a population of like 200,000 stars and like some of their properties. And then, of course, we only like analyzed a sample of it. But, you know, it wasn't necessarily to predict anything. It was just to be like, oh, this is the median or the mean size of the star, distance, angular velocity across the celestial
and then
sky.
You can do a lot about stars in that same group or in that same cluster, right? So that's the same thing. A lot of times when people say, oh, you know, there's so many people in the world, or like they make some assumption about the population. That's not because they actually have every single person taking a survey. No, they take a sample of people, and we're definitely going to get into what all these things are, like a random sample and stuff like that, where they take a sample of people, and then based on those properties and those analysis, that analysis, they assume things for the population. That's the whole idea. You take a sample and you assume for the population. That is basically the study of statistics. And the reason it's important is because it's seen everywhere. If you ever want to hold a good argument up against anyone, you're going to need some form of statistics somewhere, right? You're going to need some sort of argument, some sort of number, some data that represents some event happening that goes in or against your favor, right? So the whole idea is basically just data, taking in data and summarizing it in some way depending on what we need from it, right? Study of statistics right there.
Yeah, and also one thing that I want to talk about is like normal distributions as well as like the z-score.
Oh,
you know what that is, right?
Yeah, of course. Of course.
Which is super important and also
I'm gonna get into it.
Like it's so easy, quote unquote, to like find a z-score, and it tells you so much good information.
Yeah,
right.
So
we're gonna talk about that. But the first thing that we're gonna talk about is events. And
simplest thing.
Rayhan, kick it off.
Simplest thing, event. Well, what is an event? So the whole idea, before we even get into like actual statistics, right? Actually like analyzing the data. Well, we have to understand, well, what is the data, right? Like let's dive a little deeper into the actual data itself. So now this is interesting because if you guys have watched the previous episode, episode 70, which we did with Matt Cater, super awesome guy, super awesome episode. We spoke about some really cool things about functions. And a lot of that is actually relating to what we're going to be talking about today, because a fundamental property about all statistics is a set of events, a set of numbers, a set of something. And the whole inherent property in functions is to take a set and to do something with it, right? Anyways, I'm not going to go into that function thing, but I just wanted to make the relationship between this episode and the last one. But anyways, so the idea behind a set and its importance is we have something called the universal set. In all probability textbooks, in all statistics, questions, anything, we have this thing called a universal set, which is basically the set of every single thing that can happen. So let's say, for example, we have only access to 100 numbers, the first 100 numbers. The universal set will be the set that contains 1, 2, 3, 4, all the way to 100. That's the universal set. Now, I'm asking you, I want only the even numbers. So the even numbers will now be a subset of that universal set. And that is what we can call an event. Now, in this situation, any sample, any subset of the universal set can be called an event, right? And the idea behind that is, again, how we define an event is different. So in this case, I can be out of the first 100 numbers. If it's even, it's, the event occurs when it's an even number. So every even number, you will put it into this one subset, and that kind of takes it, right? And then that you call an event space. That's your event space. So again, just diving into a little bit of the nitty gritty of the data before we get into the probability and the statistics, right? And the event space also has something similar called the sample space. A lot of words I'm throwing around here. So a subset of this universal set, right, which contains everything, including the event space, is something called a sample space. Now, this is with everything that you are dealing with in your experiment. So let's say, again, we had access to 100 numbers. And in this particular variation, I'm only using the numbers until 50. So the sample will be 1 to 50. And again, this example might not make, you're like, where is any of this going? Believe me, when we deal with populations, it's going to make a lot more sense, right? So a sample is just a part of the universal set, an event, and is basically technically a subset of the sample. It's not a direct a subset of the universal set. Because the idea is, okay, in the sample that we're taking, because remember, we don't always have access to the whole universal set, right? Like in the real world, for example, we don't have access to every single person in the world, but we have access to maybe 100,000, maybe 1,000, right? And we can make an estimation about the whole world. So that's the idea. We take the sample, there's some events in that sample, and these are all just sets. These are all just sets of numbers, sets of information that goes inside, and we're making inferences about all of these sets. I mean, and that's basically the idea.